Hi everyone, this is John Wen. Today is February 17th, 2021. In today's video, I'm going to go through the research updates since the past week. I'm still working on the deep learning workflow in DataView, and I also spend a amount of time in the CUDA side to do the neural network. So the first item I was working on in the past week is to finish the implementation of feeding the CUDA neural network with input data. So right now, our CUDA neural network is able to be fed with a Cipher10 dataset. So on the left-hand side, there is a screenshot of description on the Cipher10 dataset. And this is a dataset which contains 600,000 images, which is all 32 by 32 pixels, and they are in 3 channels RGB images. So we split them into 6 batches, and each one contains 10,000 RGB images. So basically we're using the 5 batches as training purpose and 1 batch as a testing purpose. And right now our CUDA neural network is able to run with following structure with its input data. So because we have 32 by 32 pixels and we have 3 channels, so the input neurons of the linear layer will be 3072, and this includes all the pixels. And if we have the convolution layer later, maybe we can decrease its number significantly. So right now we only construct with a linear layer, rel layer, and sigmoid layer. So maybe you've already noticed something abnormal. So as you can see from the screenshot here is a running result, and we are reading 30730000 bytes every time from every batch. So here is printing something to show we are indeed read from input data. And here is a construction of the neural network, and you can notice that the cost is NaN, which means it's not output any meaningful data. So I think that's because we're still using the sigmoid layer, as well as a cost function. We're still using the binary entropy cross entropy, so that because we were using that to classify the binary classification in our last example, but right now we have 10 categories to classify, so that will be a problem. So the last layer, as we say, still be the binary cross entropy. So for sure it cannot classify 10 class data. So I will work on to adding maybe a softmax layer later, which is able to tell, here is an example, which is able to tell which category it is and which category has the highest probability, and then we will choose that to be the result. And the second item, many thanks to Dr. Lu, we had several discussions via the phone in the last week, and he reminded me about the API design in the DataView neural network workflows. So I think that is very important, and here is one example I can think about. Maybe we can design some language and to let user to define the neural network in the workflow layer. So here is an example of the user's input. We hope only to simplify the user's input as much as possible. And firstly, they will specify what kind of neural network structure they want. And maybe the hyperparameters will be included in each layer. And then what is the input data and what is output file. So here is an example to construct a neural network. And here is the API or language, how user can use this interface to construct their neural network. This is equivalent to the txt file we had before, which is going to construct linear layer with 2 input neuron and 5 output neuron, and then a rel layer, then again a linear layer and a sigmoid layer. So here is a graph of this neural network which can be visualized. And next, I was working on the revision of the submission on journal papers. And we are about to split this journal survey into 2. And first one is about survey on the workflow scheduling algorithms, and the second one is about workflow management systems. So we hope to be focused on each one and hope to make them a full story. So I just started to separate these two from original paper, and I will keep working on to refine it, and maybe we'll send to Dr. Lu and Dr. Che soon. And meanwhile, I will check out the suitable journals to be submitted with. And last item, I was playing with a lot of hardware since the past week because on last Thursday, I think, my laptop was dead completely, even though I connected with AC power without the battery connected, and it's still not be able to power on. So I suspect that is a CPU, maybe that is a dead CPU issue. So I try my best to construct a PC as soon as possible because I have many things to be working on. So originally I was planning to pay myself, but many thanks to Dr. Lu, very generous support. He support me on this. I really be grateful about this, and hopefully all the things will be paid off. And also we're thinking about to set up a GPU cluster locally, and maybe someday we can hold into the data view system in Wayne State University, and people can feel free to use these GPUs when they're available. So the top one is the NVIDIA Jetson Nano, which includes 128 CUDA cores, and there's also a CPU, so this is a system on board. And the lower one is more powerful, which called the NVIDIA Jetson Xavier NX, which includes 384 CUDA cores and 48 tensor cores. Basically, the tensor cores is more powerful than the CUDA cores and is more specified to calculate the matrix multiplication. So hopefully, we will set them all soon, and we will have 4 of the Nano and 2 of the Xavier for the trial. So hopefully we can make full use of them. So I think that's it for today's video, and hope you enjoy. Until next time, happy coding.